thanks for having me here. I have to get on my own calendar when the plant sale is. It sounds like something not to be missed. I think we're all happy with turn of the weather, right? Finally springtime and thinking about all that wonderful summer activities here. So thank you again for having me. I'm really excited to be able to talk to you guys about the Gloucester Marine Genomics Institute, otherwise known as GMGI. I know it's a mouthful, but it's great to do this because we've been here in Gloucester. We just celebrated our 10th anniversary last year. So we were founded in 2013. But it's remarkable the number of people who are still just beginning to learn about GMGI. So every opportunity we have to tell the story and answer questions is just another node in that network of helping us expand our base of people to understand what we do and what our impacts are. So GMGI was founded under the idea that the ocean can continue to be a source of opportunity, not only for Gloucester and Cape Ann and the North Shore, but for the world. And especially in Gloucester, which has an incredible maritime history, that fishing fleet, that history of fishing and all the associated jobs that came with it has been rapidly dwindling over a number of years. The fishing fleet is about 70% of what it once was. And in that are jobs and opportunities for local families, local young people to thrive and stay on Cape Ann. The founders of GMGI, many of them were biotech founders, scientists, and they had these incredible careers in Kendall Square in Boston and the 128 belt, which, as I'm sure all of us know, is a global hub for innovation in science. And they said, you know, we have had incredible outcomes in our own lives. We've discovered drugs and, you know, we've created things for industry using biotech and science. We also love Cape Ann and we love Gloucester. And Gloucester is going through hard times. What if we could bring and bridge those two worlds together? And they came up with the concept of, let's do genomics. So genomics is DNA. It's the study of all those, like the smallest building blocks that create life. We are all DNA, and our DNA gets entwined together and codes things, and then follow that train down, and then we're humans, or a dog, or a flower, or whatever. But genes and the genetic code is what makes life what it is. The ocean is teeming with DNA and with life, and so many things we can understand and could be used to make the world better. So our scientists, our founders said, let's, like the fishing fleets before us, go back to the ocean, but use a different technology, a different way of thinking about the ocean and science and discovery. So we founded the Gloucester Marine Genomics Institute, and down on 417 Main Street, a big orangey-red building, which we all have driven by many times, that's where our research institute is. So our scientists there are looking to the ocean to understand it better, and then to also make discoveries that could impact the fishing industry, our understanding of the populations of fish in the oceans. We have a sustainable, long-term fishing industry here in Cape Ann, but also novel compounds and chemicals and proteins that could be used to cure cancer, or could be used to create industrial products that are more sustainable for the environment, for the world. And there's lots of other things that happen at the Institute using genomics and molecular science in a really specific way to unlock mysteries that can help the world. And I think what then pivoted from that work was, well, what about the young people? So if you're a scientist, you're a genomic scientist, you probably have a PhD, you've probably been through higher ed, and that's great. But Gloucester had all these young people that were being left behind because all those fishing jobs were drying up. So then, again, the founders said, in our labs and the companies we founded, we have so many entry-level lab technician roles, jobs that are for young people, and they don't need a college degree. They just need to be really well trained. Think about any of your vocational jobs, your plumbers, your HVAC, your electricians. They were just people that were trained in a really robust skill, and they all have incredible lives and jobs working in their trade. Well, life sciences and biotech, being a scientist at a lab bench, using all that equipment and helping a company grow, that can be learned. So we opened up the Gloucester Biotechnology Academy. This is a program where we take high school graduates without any science or math background or expertise, many of which are not on a path to college, are living in poverty. Parents maybe never went to college, and honestly, their guidance counselors and their teachers are saying, you're not, good enough. You didn't do well in high school, or you have, social and emotional issues, or you're a single mom. There's limited things you can do with your life. This is what they've been told. And we bring them through a 9-month program, 7 months at Gloucester Biotechnology Academy, where we give them all the skills they need to be successful in the life science and biotech sector. And then, once they graduate from that, they go on a paid 3-month industry internship. So they're making $20 to $30 an hour for 3 months, where they're putting all that they learn into practice. And then after that, they graduate from this program. So, start of a 9-month program, you're working at Dunkin' Donuts, they have an hourly wage job somewhere, no path on what they're going to do. 9 months later, they're getting jobs in Kendall Square, Dana-Farber, all the biotech companies, and Cummings Center, and we hire some of them too. And starting salaries range anywhere from about $45,000 to $75,000 a year. And these are young people that many of them literally did not have options. Not only do we give them those skills, but we have to instill in them the confidence to succeed in what is a very professional work environment. So again, you worked an hourly wage job, you just graduated high school, you've never worked in a professional company, that's a huge roadblock. You just throw them into that company, and they might fail. So we have a really robust life skills curriculum where they learn about personal finance, they learn about how to negotiate for a raise. We talk to them about credit cards and how not to get into credit card debt. And we give them all the tools that, again, many of them don't have anyone in their life to give those tools to them. And then they're also paired with a mentor. New England Biolabs, which some of you may be familiar with, is a biotech company in Ipswich, and many of their staff mentor our students. So there's a mentor there to help them through the internship component and on to graduation. At the academy, we admit about 45 to 50 students a year through 2 cohorts. So one cohort will start in August, and then they move through the program, and then about 3 months later, that second cohort starts. And we do that just because how the academies, the logistics of getting students through, there's a couple different learning labs, and we can't have all of them go through at once. We need to have the first one kind of go through and then leave the space for the second one, and then they go through that program. Our graduation rate is about 90%, which is fantastic because the average graduation rate in America for a 2-year associate's degree community college in 2 years is about 14%. And when you look at even 4-year, I think UMass Amherst for undergrads to graduate in 5 years is still like in the low 70s. So the fact that we can get usually the mark is usually 85 to 90% of our students to graduate is pretty fantastic. And then an additional, of those graduates, about 95% of them stay in life science or biotech, or occasionally some of them are inspired to get their undergraduate degree. It's not the purpose of the program. The purpose is to get them on a fast track to a successful career quickly. But if they do get that confidence that they can succeed in learning, they can succeed in finishing a program, and they want to get their undergraduate or a graduate degree, then we're happy with that too. And like I said, it's a really fantastic program. I see many faces here who came for the tour this past summer. Love to have you come and see the program, meet some of the students, and tour GMGI. And I think I've covered most of the bases on GMGI, so I guess I'll turn it over to you if you have any questions for me.
I have a question. I'd like to know where your funding comes from normally, and you are a nonprofit, correct?
That's correct, yes. So GMGI is a not-for-profit. All of the gifts that have, what I will say is, at this point, 10 years on, we are only where we are because of the generosity of donors. The Academy is mostly funded with philanthropic gifts. My team and I write many grants. We host parties and engage with donors and bring people into the story and hope that they feel inspired to support the program. And the state of Massachusetts does give us some funding that we have to apply for. We'll just cover some of the staff salaries for our teachers. We have 6 teachers at the program. They're fantastic. Without them, the program would not operate. And going forward, what the founders realized was that to compete for some of the best science grants, so our researchers are all top-notch scientists, and they want to compete for National Science Foundation and the big national foundations that give away lots of money for science research. We're competing with the best universities in the world for those grants. So to get the research to the point where they have all the data and knowledge and publications to be able to compete for the top grants, we've had to backfill that with philanthropy. So our researchers are just getting to that point where they are competing for some really great grants. And that history of getting us to where we are today was almost entirely private foundations and individual donors. Yeah.
Wonderful.
Yeah.
Do the waiting list for applicants, or do you find it easy to fill schools?
That's a really great question. Yeah, the question was, do we have a waiting list for the applicants at the school? And what has happened, so since in 2021 was when we doubled the size of the program. So it used to be about 25 students a year, and then we doubled the footprint of the academy with a new biomanufacturing learning environment. I didn't go into details of what all the labs are, but we teach biomanufacturing, which is the future of manufacturing. When we doubled that, we were able to double our class size, so upwards of 50 students. That did mean that we needed to reach out further and we needed to recruit more. Luckily today, primarily from massive amounts of outreach to social service agencies and schools up and down the North Shore, to word of mouth from students, we get lots of applicants, and we do a really careful interview process, because we find that for the right student, this can be a life transforming program. For the wrong student, if their parents are pushing them or they're not quite ready for it, they might drop out after month 1 or 2. Well, it's only a 7-month program in the classroom. If someone drops out at month 2, we can't fill that spot. So we want to make sure that the students that show up on day 1 want to be there and will graduate. And I actually think this year we might be more like 98% graduation. I don't think we lost 1 student. So we've really learned how to pick students that are going to succeed, but pick them not because they're the smartest and the best and have the best record. We want to pick students that want to be there. And we just don't cream off the top of the best students. It's really, I think, valuable to ensure we're giving them all the best pathway.
Have you had any big breakthroughs?
At the research, yeah, so, what's really interesting is that, so I'll give you a few little snippets. Andrea Bauermeier, who's our science director, she uses sea urchins to study aging and cancer. Fascinating fact about sea urchins, about 85% of their genome matches our genome, so they're actually a great model for human health discoveries. We often think about like mice and chimpanzees and fruit flies as being organisms that we can do experiments on, and then say, oh, what did we learn here? And now let's apply that to humans. Sea urchins are the same. We can learn a lot from them. So it may not sound like a big win, but when you're doing experiments on organisms, right, you can either keep them in the lab as a full organism. And that's really challenging. You have to keep sea urchins alive, or chimpanzees alive, or fruit flies alive for a long enough period of time to do your experiment. So what science does is it's called cell culture. So you can take a cell of a sea urchin, right, and you can grow that cell in a dish, and then you can do your experiment on the cell, instead of having to actually keep the sea urchin, or the chimpanzee, or the fruit fly. So cell culture, that's a skill we teach our academy students. Huge skill industry. Many of them get hired very quickly for that skill. Cell culture is really valuable. No one in science has figured out how to create a cell culture of sea urchins. The biggest issue is when you're growing a cell in a dish, you have to feed them. You have to give them the right oxygen and pH and food, because they're living things. They actually have to thrive. No one figured out how do you make a sea urchin cell grow on a plate. So science was never able, they just never did it. So actually last year, our team discovered what is that perfect growth media? What is that perfect, fluid and all that good stuff you can put in a dish that'll make sea urchin cells grow and thrive. So with some of our partners at Brown University, we figured out what that perfect growth media is. We just published a paper in Nature to put it out to the scientific world. So it's a small win, but it basically will now allow scientists anywhere in the world to say, I want to use sea urchins, I want to use them because we can extrapolate that and learn things about humans. And now GMGI has told us how I can create that perfect home for them in a plate and then do their experiment. So that's, I think, a big win recently. And for us, we're going to use that to look at anti-cancer. Sea urchins don't ever develop cancer, so we're going to figure out why is that. Some sea urchins can live upwards of 250 years old. Why is that? If they're so similar to us in DNA, why can they live that long? So those are some of the questions that we're looking at now. Yeah. Yeah. Yeah, definitely. Yeah, it was. Yeah.
One of the things, I listened to the lecture series, you know,
Okay.
much of the people who maybe know about that, about Zoom lecture.
Yeah, so in part of this outreach, getting the information out there, we have what's called Science Hour. So it's a virtual lecture that we put on, usually about 3 or 4 times a year, generally in the winter months. But we scour the world to find marine scientists that have a really fascinating viewpoint on their area. And then we bring them to GMGI and we'll do a science lecture. And we get great attendance. And I think what we love about it is that at the crux of GMGI, and we talk about academy and biotechnology and cell culture, we are an ocean-centered not-for-profit. I mean, we all live here, we love the ocean. The ocean is our own backyard. So that really is the key. Like, you could not exist anywhere in the world but here in Gloucester, because we love the ocean, we're going to the ocean, and things like the Science Hour is the way that we can bring global ocean research to people locally. Yeah, good. Okay, awesome. Thank you very much.